Hello, everybody, and thank you so much for having me. I've had so much fun talking to all of you before I ever got up on this stage. This has just been such a great experience. So thanks to all of you already, and thank you also to the organizers. So as Stage has said, I am Rebekah Callari Kaczmarczyk. There will be a quiz on how to spell my name at the end. And I am a senior software engineer at the Philadelphia Phillies, and today I'm talking about making it to the DataViz big leagues, because who doesn't love a pun? And in not layman terms, but in front-end web developer terms, what we're actually talking about is how do you take a software team where the lead on the project is a big fan of a pretty complex low-level library and has come to the conclusion that the rest of the team needs to move to that library also. And so this talk is about visx, but it's also really about that transformation. So I work at the intersection of data science and application development. When you saw that really cool line chart that you've seen multiple times today about like this line of the API, my job actually straddles both of those lines. So I partner with our data science team to determine how they create their outputs and store those outputs. I write the APIs to interact with those, and then I build the tools that do that at the end. I forgot to give a warning to any of my Padres fans. I'm not sorry. That was a great experience. So I also am a co-organizer for the Women in Sports Data Hackathon and Symposium, and I'm a volunteer at Code the Dream, where I work in both Python and React course development. Other things that bring me joy are art museums, romance novels, hockey, and yes, baseball outside of work. So because I'm talking about kind of the move and change of a team, I want to give you a little bit of overview of who this team is. We're a team of 4 application developers. We're all full stack. The tool that we build, the application, is, pun intended, game-changing. We work with ML coaching staff, baseball operations, player development, and scouting. Those are the people who use our tools. And what we're delivering in data to them is the work that the research and development team, our data scientists and our other ML engineers and software engineers have designated and created. Our stack right now is React, TypeScript, Python, and MySQL. That MySQL part is kind of in change right now. So this is not an ad for visx. I love D3. I love visx. That's not really the goal of this talk. The goal of this talk, as I said, is to talk about that transformation from a tool that maybe is a little bit easier to use but doesn't fit your context as well to a tool that's much harder. I'm going to spend a little bit of time actually talking about visx and how we implement it. If you want to talk about that more, please come find me afterwards. That would be like a whole other talk. So the other really big clarification here is the Braves are 7 games behind, and we want to keep it that way. So you are seeing actual React components in the DataViz that I'm going to show you. It's actual code that's within our code base. But the data that I have passed to these React components and the analysis that it's displaying is not what is in our internal tool. So if you're a baseball nerd, this baseball data comes from Baseball Savant. I pulled Zach Wheeler's pitches from earlier in the season, because getting a lot of data from Baseball Savant can be tricky. And it's really surface level analysis. It's not even really analysis, it's pretty much just descriptive in the DataViz that you see. But the components are used to actually show other data and research that we have, so you get a taste of what this might look like. So before visx, and another kind of bit of a tangent, all of the tapestries have meaning, so talk to me afterwards if you want to know what the hidden meanings are. So I joined the Phillies about 4 years ago. I was a sicko, and when I learned how to code, I wanted to build arc diagrams to show the linguistics research that I was doing. And so I learned D3 actually as part of learning how to code, within my first year of coding. So when I came to the Phillies, I had a DataViz background, both in low code, no code, and code situations across Python and JavaScript, variety of libraries. And at the Phillies at the time, the internal application that the full stack team developed was pretty low in analytics and DataViz. It was mostly other sorts of functionality, and most of the data science team was deploying their own internal apps through things like Dash or Shiny. And so at the time that I came in, there was a project where we needed to convert a Shiny app, and so I was kind of put on that project of there's existing DataViz in a Shiny app, we now want to do that in the full stack app. And so in the process, I did some research, kind of talked to the rest of the team. We were slightly smaller than we are now, but not by much. What have you all used? Nothing other than high charts, which is already in our code base. What do we need? We need to be able to build contour plots, which is something you can't do in high charts. How much time do we have for this project? Never enough. There's never enough time, right? And so at the time, I decided to add Plotly to our code base. And I don't think that was the wrong decision at the time. But in the process, I very quickly started encountering situations where I was spending more time reading the documentation on these or fighting with things that they had already done that I didn't want to do in that way. So some examples of that, and this is actually a viz built in Plotly that's still active in our code base now. When you talk about visualizing data in the strike zone, you're on the same scale on both the x and the y axis. Well, we don't actually call for the vertical y, we call it z. But anyways, on those two axes, it's the same scale, right? It's inches, feet, meters, whatever you're gonna measure it in. And so you need your pixels to value ratio to be the same in both your height and your width. And almost all plotting libraries optimize for plotting with the amount of data and the amount of space to fill up the amount of space with the amount of data. So you can actually distort your strike zone if you use defaults, and it can look wrong, which is not a great idea. So in both libraries, I had to spend a ton of time reading how do you do this, and figuring out how to do it. And it was a lot of extra code for something that at least I thought was pretty essential to data viz. But I'm in a pretty specialized area, and they can't cover every use case. With that, I have really strong opinions if you talk to me about this, about effective use of color scales, and I can pull research for you on that. And a lot of the defaults are not following those best practices when it comes to either interpretability of data or accessibility. The two are very closely tied. And so a lot of the defaults in Plotly, I had to spend a lot of time figuring out how to generate the color scale that I wanted that matched the research. I also had limitations on annotations. This one's pretty light, but we sometimes go a little wild with the annotations. And in high charts, I think weird is probably the wrong term, but that's what fit best on the slide. What it really comes down to is high charts made assumptions about how I would use their charts, and I violated those assumptions, which is okay, right? They can't build for everybody, but then I had to write a whole bunch of extra code in order to counteract that. So with this, our team continued to grow, our data science continued to grow, and the direction of our product also changed. And so we decided we really wanted to add a lot more data viz, significantly more data viz, and we really wanted to focus in on this data-driven decision-making as what the purpose of our app was. And so about a year ago, my boss approached me and was like, it's your job, you're the one who's gonna spearhead the project, figure out what we're gonna do with our data viz, and let's actually make it effective. And so in the process, did a lot of talking, have to give a shout out to Peter at Netflix. His last name I don't remember at this time, but he's really good at D3, talked to him, talked to people on my team, did research. My automatic thought was we should use D3, but D3 and React are kind of a little strange, and we'll talk about that a little more. And he was the one who actually kind of confirmed for me what I was already thinking, which is that visx was our best choice. And so a little bit about the terminology. D3 is a low-level JavaScript library used for web data visualization, primarily for manipulating SVGs. It's been around for about the same amount of time as React. It still reads and writes like it was written a while ago. But it really is one of the few that's out there that allows you to do this low-level stuff without having to do all the math yourself. And visx is created and maintained by Airbnb. It's an open source library, which is a lightweight D3 React wrapper. So why visx? First, that DOM debate, right? Created around the same time. The creators of D3 didn't ever do a React wrapper themselves. How do you manage the virtual DOM with something that's interacting directly with the DOM? visx kind of abstracts that part out for you. In addition, visx is written in TypeScript, and they've tried to get away from as much of the interesting things that D3 does with data structures. And so, obviously, that's a really strong preference for us for things to actually be written in TypeScript. It's also very modular. So it's not just split into multiple packages, it's also built in a way where you can add components as you want, but you can also just straight up build vanilla component elements yourself. You can pull in other things that also can render on an SVG. It's very much something where you can pick and choose what of it you want to use. And it comes with pretty much all of the flexibility of D3. So I will say in many ways, it has the same steep learning curve. In many ways, you're still going to have to understand the underlying D3, but you at least can write it without having to worry about the React element. You can write it in TypeScript, which makes things a lot easier, and you also can write it in like a more modern way of writing code. So, how did we successfully switch? I love D3, but how did I convince all my teammates to do that too? So I think with this process, I say process, but there's no numbers here because all of these things were kind of done repeatedly in an iterative fashion. So I think the biggest thing when you're making a change is getting buy-in, right? And you need buy-in from the people who decide whether or not you still have a job, and then you also need buy-in from the people who are gonna do the work with you. I really did not want this to be a mad scientist project where I was the only person who did this, and I was the only person who maintained it, and when I left, it died. That really was not the goal of this. And so I worked with both leadership and my colleagues from the beginning. I involved them in the decision-making. With leadership, that was more about communicating trade-offs and why this was a better decision. With my coworkers, as I was kind of testing and prototyping, I was reporting things to them, getting their opinion. I was given the final say on the project, but we have a really strong philosophy of disagree and commit, and so as a team, we did decide to commit. With the prototypes, you obviously don't add something without prototyping, but from the beginning I was building a prototype, experimenting in a sandbox, but also kind of documenting it in a tutorial style. Here are the things I'm learning and doing and why I'm doing them. And even now we use this practice. So we haven't built every possible plot or chart type, and so we still always start with a prototype. And we completely move away from fetching data, like we don't worry about that at all. We don't do anything asynchronous. And we pretty much just exclusively pass in some data and plot it. We experiment with it, we agree on it as a team, and then we move forward from there. Throughout the process, creating guidelines and guardrails, right? So as I saw places where shared helper functions would be useful, or shared guidelines or different things, I started adding those things, and I'm still adding to those. And then we strongly ascribe to deploying early and often, to the point that the version alpha, which was for a test group of users, had no hover functionality. And we told them, you'll get it, but not in the alpha version. And then in beta, we add hover. So how do you knowledge share? I think one of the biggest things with a new, pretty complex thing is the PRs need to be really small. It's really hard to understand and effectively review a lot of code, especially if it's something you're not familiar with. And so this is part of why hover functionality is almost always done in a second PR. If you've ever written hover functionality, like in like a canvas or like SVG elements, it's a lot of math and it ends up with a lot of code. And so you start with the PR small so that everyone participating in the PR process can really read and understand and ask questions early before a whole bunch of decisions have been made. The documentation, kind of already alluded to this, but this is documentation at multiple levels. So I'm writing guidelines about best practices, how we use the library, all of those sorts of things, so kind of at a higher scale. But it goes all the way down to, there's this really bizarre thing that D3 does, and so in this exact line right here, you can see that this is why I'm doing this thing. And then, of course, component prop documentation, kind of some of your standard stuff. We're not like, I'm remote, so like in-person collaboration is limited, but we really try to get a lot of value out of it. So some of these meetings where I'm gonna go over some of the pros, cons, this is where we're at to make a major decision, we might actually have a meeting for that. And we've also done periodically pair programming of somebody who either just wants like a brief overview of how something works, or there's some sort of weird bug that somebody's having difficulty solving. I'm oftentimes the one pulled in as that other person in the pair programming, unless I'm the one stuck and then I'm pulling someone else in. And then shared work. I love this work. I get super excited every time we get to do it, but I don't take all of those tickets because you can't learn unless you do. And so you can, but you're never gonna learn as well. And so making sure that once some of this stuff was already set up, once some of the initial stuff was done, then immediately start moving into sharing the workload with other people so that they can also learn and do themselves. So the code. I'm not actually going to show you code. I'm going to just talk about some of the general principles of how we write the code. We've taken this philosophy of start specific and generalize with purpose. Obviously, we want our components to be reusable, but on a team of 4, where the primary goal is to build things that the users can actually use, who are not programmers, not a plotting library, the goal is not to create some sort of open source recreation of high charts or Plotly. It's to create really effective plots that are engaging and help our users make good decisions. And so we do want our code to be reusable, but we're not trying to create the most generalizable code out there. And so we generalize when it makes sense or when we can see a clear pattern of repetition, but we don't try to predict all of the things that might come up that we might want to generalize in the future. And we also have taken the mindset of the code today will not look like the code in a year. Because in a year, we'll have a better sense of all of the edge cases and all of the requirements, and we'll probably need to build in time for some refactoring in the process. And I'm not talking rewriting everything. I'm talking small iterations on that. So, how do we build the React components? This is building on the work of a ton of people who have used D3 successfully in React, people like Shirley Wu, who's presented here previously, of basically you take out all of the work with wherever you're getting your data from that is async and has to work with some type of server, and you separate that from the visualization itself. And we did this first because it works really well for us. Second, because our data is, like, the data portion is very strongly coupled to the actual data compared to the presentation component, which is not. And then also because we would love for Airbnb to continue to maintain this forever, but there's always a risk that, especially when something is maintained by a company, that they'll decide that it's no longer useful. And so using this pattern kind of gives us a safety net that if visx was no longer maintained, we can very quickly switch over to just vanilla D3 and kind of doing the DOM management ourselves. So our data components are our parent components. They're tightly coupled with the data that we're fetching from the API that we write ourselves, for better or worse. And we do our fetching and transformation and formatting of the data in this component. So this is where we're going to handle any sort of transformation we need to do, any sort of filtering. All of that is going to happen at this layer. In addition, unless it's very, very tightly coupled to the output of the plot, if you can actually interact with the plot by filtering down the plot, it's probably going to happen at this level. We then pass that data to a presentation component. The presentation components are relatively data agnostic, other than X values need to be this type or things like that. And then these components are what inherit and display the data. The only transformation that's happening here is just to get your data on an X and Y axis or whatever it may be. We leverage TypeScript generics with these components to make them more reusable. These components are going to have pretty tightly typed data of it's coming from this API endpoint, it should look like this. These components are going to be much more generic, and we're working out the final kinks on even like being able to specify some of the more complex implications of that. And then because we want this to be reusable and we knew this was a use case we want, sometimes we want to fetch and store our data in a parent above this parent because we might display multiple plots on a page and we might want to only fetch the data once and then pass that same data to multiple. But in other situations, we only want to display one plot, and it's kind of a mess to have to take out of this other parent that has other stuff you don't need and have to move that over. So all of our data components can either inherit the data or they can fetch their own. There's a Boolean that will use either of those situations. So we can optimize by fetching further up, or we can do it and control it within the component. So what was the outcome? So some of our successes, we have successfully deployed multiple more impactful features. And for us, more impactful, we have a couple ways of defining this, but we have had really, really positive feedback from our user base. We've also, with some of our internal metrics, we would consider this a success. And every person on this team of 4 individuals, despite none of them being as obsessed with data viz before or after this process, has contributed to these components and can continue to do so in the future. And we have successfully reused our components, because you'll be like, oh yes, they're reusable, and then a year later you go back to use it somewhere else and you're like, oh no, it's not. So we've actually proved it works for us. And we'll need to make more changes, but it works for now. So what were some of the challenges? We have an older code base. I mean, I don't have to explain that. And so there were some dependency conflicts. In addition, there's some complications to how we want to implement type checking that we're still doing a little bit of casting that I would like to get rid of, and I need to kind of revisit again. But it generally is type safe, and it does the type checking we want it to do. And then there's this process of balancing short and long-term goals. At this point, like, we have a ton of leadership buy-in, but at the beginning, it obviously required a lot more convincing. And with that too, a lot of this work it did cause a decrease in velocity. The value at the end was worth that decrease in velocity, but there was a slowdown, and so there were times we had to make other decisions. And these contour plots are a really good example of that. With this also came a lot of data redesign, and that's something I've been doing for a while. So the color thing is something I actually fought a couple years ago. But if you've ever looked at public baseball data analysis, they really like this like multicolor weather plot style, and if you are colorblind, you're like, what is that? Because it's not viewable if you're colorblind. And that's just a really bad data viz. And that's, again, like a whole other talk, but it's not colorblind accessible. It doesn't really tell the data story as effectively. It kind of misconstrues the data. And so we obviously want to use something better. So that is obviously like part of this process has been, we haven't just changed our code, we've also changed some of our practices. And so some of the things similar to this have required conversations, collaboration, working together to really come to the conclusion of what is best for us to use. In addition, this is a really good example because we had contour plots like this in our code base before that I had built using Plotly. The backend I had not built, and it existed because of previous decisions that were made, and the backend needed to be fully redone. And we needed to make the backend where it was reusable for multiple types of data sets. We needed to get it into something that didn't take 30 seconds to do the calculations because of the endless loops in Python. And so when I needed to get this out for the most recent project, I wanted to rebuild the contour plots in D3, but opted to rebuild the backend. And so the next time we have contour plots on the schedule, I'm going to build in time to convert them to D3. So it is a process. We're still using multiple things, but overall, we have code we're happier with and also data viz that we're happier with. So what were some of our keys to success? I don't think any of this is earth-shattering. I think it's all stuff that's pretty obvious, but it's worth repeating. And so I think iteration is really key, right? So we're iterating on our code, but we're also iterating on our process and our product. Within this process, we have done things like this before as a team with not as much success, and we've learned from those failures, and we have iterated on it again. We've then reflected on this process, and we have plans for how we'll do things differently next time. And we manage all of our own product, and so we also have to do all of the product work of that too, of iterating on the products, getting feedback from users, and improving those. And with that, I have to shout out my team. Like, so much of this was successful because we have such a highly collaborative and engaged team. The fact that we so strongly work together, communicate together, we work across our projects quite a bit, that it was not me coding or making decisions in a silo that people were then not supporting. And so that was a huge factor in our success also. So that's all I have. Thank you so much. If you'd like to talk further, please come talk to me. I will be here for the rest of the day. In addition, you can find me on LinkedIn if you can figure out how to spell my name, or you're welcome to email me. I've also, this is very much a work in progress, but this GitHub is where I'm kind of occasionally posting simple code snippets of how you would implement visx, because as awesome as the library is, there's not a super active community online with examples of how you'd use this code. So I'd love to contribute to that. So yeah, I'll post my slides in the slides channel once I'm back in the hotel, and thank you all.